It's a real privilege to be working on a building like this. It's once in a lifetime opportunity, and we've been privy to some of the original drawings from the job. In fact, some of the original drawings we're still being used at the moment. It's just that advancement in technology from back in the 60s when this building was being designed and built to now is quite incredible. I've literally been to every part of the building, really proud to be part of it and work with Arab and tailors to deliver the concert hall.
I'll share a secret. I've actually never watched a show inside the concert hall. But now, for the last 6 months, I'm coming here every day. It's an amazing experience. It's spectacular. All the steel structures are engineered in such a way that it's very unique. And because it is an existing structure, it's heritage listed, we have to work around what is already over here. And it's actually kind of like a maze. We're doing all the steel structures. That includes choir stall, winch room, portal legs. We have platforms we're building for the cannon ports, the acoustic banners and acoustic reflectors. From Icon Metal's perspective, we did the choir stall, so we did the whole structure. The choir stall, it was supported by timber and concrete, so that all got demolished. And then we put in new steel. We did the stage wings, the steel structures on the side.
Welcome to this in the Opera House project for Icon Metal. Here we're working, strengthening up the existing building. Well, that's seating up the top there, and underneath that is what they call the choir stall area. That's where the choir comes in at the start of a show. They get set up, they get changed. Welding new bits of steel in to support the existing stuff. You can see the amount of welding that's gone into here. There's a new bracket installed that supports the existing stuff. A lot of work through here. The boys have done a great job through here. Site supervisors, hard at work. So this area here is what we call the choir store again. The choir, once we're finished here, then the services trades comes through here. They put all the services in. Then the Gibrock finally, he'll come in and he'll sheet everything, and no one would know what's gone on behind the scenes. But without our work, nothing would work here. And that's the idea, I suppose. No one knows what's going on. I'm still proud to do this sort of work.
So on top of the stage, you have these. You have the tech zone, which is the truss itself, and then the whole truss is being picked up by 4 legs. These are called portal legs. And at the bottom of the portal legs, we have installed 50mm and 32mm massive plates. Each plate is about 1.7, 1.6 ton, and we have installed these plates to strengthen the leg. Basically, we have these 4 boots. So 2 over here and 2 more on the other side. And then these boots are connected to some rods. So the rod is connected from this boot to that boot. And these boots, they're sitting on rubber pads. So the whole thing is sitting on 4 rubber pads. So that's why when you're on the stage, when you jump, you feel the vibration, and that gets passes onto here. These 4 portal legs, plus we'll see more other different kind of portal legs as well. They're all strengthened to take earthquake stress, basically.
So what happens is the plates, material gets lifted up to here, then the boys put them on the trolleys and they skate them inside to where they have to go. We've erected temporary lifting frames that lifts them from this area up 2 levels, up to another platform area. Comes up here and we use these two electric chain hoists. It gets landed into one of these trolleys, straight to here, push it to where they have to go, which there's a bit of manual handling in this process, but it's all controlled. All the trolleys are certified trolleys, all the floors being strengthened, they can take the load. That's the first process, and the cabs get pushed along here, but you'll see where the first plate's gone in. From bottom to the top of the plate's about 8 metres of steel plate, and it's about 2.4 tonne in total each plate. So the boys just keep rotating from column to column, There's a crew installing the plates, there's a crew welding the plates. So everyone has their job and the job just moves around, follows each other. It's a well-oiled machine, it just happens, it just rolls on. Yeah, it's about 25 metres from the stage floor to where we're actually working up in the tech zone. This is where we bring all the material in from outside. You know, push the trolleys here or the cage, and then we attach it to the winch rope, and then the winch rope pulls it up to the what we call the crash deck, which is top of the scaffold there, up to the winch room. So the top of that scaffold is this area down here. So it's a two-stage lift. It takes time, but you know, I've got a few guys, so you know, we try to make it a bit easier for everyone as well.
That's with the portal leg actually. It's holding up the tech zone as well as everything above the tech zone, which is the winch room. Means 1,500 cars. Imagine 1,500 cars at the top. And this is just the bottom level. As you keep going up, you'll see the brackets all the way on the ceiling. With the tech zone, it's a very interesting spot. It's pretty much high above the stage. We install a lot of steel in there to strengthen the whole truss, and that truss is being picked up by the portal legs.
Because there's going to be a lot of technical equipment on this floor here. We've done about 6 months here worth of strengthening the existing truss frames that span east to west of the building, and you can see through here the steel that's brighter grey, and that's been put in support the winch rooms up above. All this structure here is all new, so you can see where the old meets the new. And bear in mind, there was nothing here before. It was all in space here before. There was nothing here. In a few weeks, the winches will start coming in, lighting will start going in. It'll look totally different again.
This whole structure, we have installed about 35 ton up here. So the whole weight is actually being carried by 14 rubbers. And that is there to eliminate any vibration. And as we go down, the whole load is being taken up by the truss, and then that gets transferred to the legs, which we have strengthened at the bottom. With the octopus, why is it called an octopus? Is because there's a head at the top and then legs coming down. So that's why it's called an octopus. What we had to do is reinforce the octopus and tension the whole thing so that it picks up the load and make it more strong. The way we have installed it, it has the capacity to pick up 120 ton. That's my baby. It took a long time to put it in, but it was complicated, but we got there. You know, the whole team worked together. And like I said, when we were drilling through the ridge beam, we were very holding on to our nerves because we didn't want to cut through the tendons. Then the whole concrete head will fall off. So we had to be very careful with that. Yeah. So from inside the concert hall, on the side you'll see the whole timber face. They're going to cut out those timber faces and do some windows. Those windows will have acoustic reflectors and acoustic banners. So acoustic reflectors are like material on a frame, and the frame will move, and that material will help increase the quality of the sound. So it's going to enhance the acoustic environment inside the concert hall. To access those windows, we're actually building from the inside. We're building platforms so that they can put their gear and everything and access those areas from the inside. is the existing platform. From here we'll be accessing the new platform that we're building. So this is the entry point, and then it will go inside over there. From there we access the acoustic reflectors and the acoustic banners.
There's a limited amount of contractors in Sydney that could undertake the works. Riggers are fantastic, highly skilled, and they come up with some innovative ways to overcome these issues, and I'm very grateful for the way that they approach the work and understand it, the procedures and training that we had to provide to ensure that they could safely exit from the building. How we mitigated the risks was primary focus for the first stage of the works. This involved us to discuss options for us minimising the risk of fire. We are welding over the top of the concert hall, which is made of timber. So
we have done everything safely. We have always put safety as our priority. Every time when we did something, we stopped and had a look at the area and try to figure out how we can do things and what would be the safest way to do. Every morning coming in again and thinking how we can do it differently to make it more safer.
The Opera House environment itself is World Heritage listed. You're never going to find anything like this ever again to work on. It's so different, every aspect of the job is just so different. You're never going to find it again ever. But that's the way it is, and we love it that way.